Okay. Right. So, hello everyone. My name is Ishu Anlaki Himanadan. My matrix number is 229199. So, my role in this organization is a manager. So, as a manager, I am responsible for overseeing the entire project, to coordinate the tasks between the members, and also to ensure that the deadlines between the members are met. So, my part of research is I researched on sampling techniques in order to gather the samples, and also I researched on the analytical techniques that we can use to extract data from those samples so that we can come up with a better way to overcome this problem. So that is my role as a manager.
Yeah, Assalamualaikum and hi everyone. My name is Muhammad Lukman Ashraf bin Muhammad Zaid. My matrix number is 230077. So my role is project leader, which is initial in ensuring the successful completion of a project. So I also responsible for planning and organizing all aspects of the project, including setting clear goals, defining the scope, and creating a detailed timelines. So my research is main environment problem, which is ecosystem, biodiversity, and human well-being. One of the most pressing issues is climate change, caused mainly by greenhouse gas emission from burning fossil fuel, leading to rising global temperatures, melting ice cap, and extreme weather event. So that's my role as a project leader.
Okay, hi. My name is Nurul Ain Johana binti Johan and my matrix number is 22777. I am the lead scientist. As the lead scientist, my role is to oversee and coordinate all the scientific content to ensure it is accurate, consistent, and aligned with our main objective. And my research is particularly on the method comparison section, where I will evaluate the advantages and disadvantages of different analytical techniques, such as comparing gas chromatography, GC, and spectroscopy in terms of sensitivity, cost, and suitability for the environmental analysis. And from this, I will help the team decide which method is most effective and appropriate to recommend for monitor the climate-related issues.
So, Assalamualaikum and hi everyone. My name is Muhammad Jufri Fadmin Julani and my matric number is 229146. And I'm a chemist involved in these projects. So, one of my key responsibilities is overseeing resource recommendation, which is a crucial part ensuring that all the analytical work we carry out is both effective and sustainable in the long term. So, in analytical chemistry, the quality of the result we produce is deeply influenced by the types of resource we use, from instruments and chemicals to human expertise and data systems. Every element plays a significant role. So, my role is focuses on identifying this essential resource, evaluating their suitability, and recommending what's needed to support accurate, reliable, and cost-effective analysis throughout this project. So that is my role.
Okay, Assalamualaikum everyone. My name is Farahia Anzalaika binti Masnawi and my matric number is 230429 and I play a role as a chemist in this research. And I would like to briefly share to you guys my role that I played in our company's climate initiative. My task was to research and identify the most effective analytical technique to monitor and understand climate-related chemical changes in our environment. After evaluating several options, I elected gas chromatography for detecting greenhouse gases like methane and carbon dioxide, and high-performance liquid chromatography (HPLC) for tracking pollutants in water and soil, such as nitrates, pesticides, and industrial chemicals. GC has allowed us to analyze trace level gases in the atmosphere, while HPLC helped us assess the chemical impact of human activity on aquatic ecosystems. I developed the sampling protocols, validated the method, and worked with our team to interpret the data. This technique are now integrated into our 5-year climate plan, which now supporting solutions like emission control and cleaner waste management. As a chemist, I believe our role goes beyond the lab, and we provide the data that drives real-world change. Through analytical chemistry, we are transforming invisible threats into measurable action. And that, for me, is the power of science in fighting climate changes. And that is the role of analytical chemistry in our research. Thank you.
So hello guys, how's the research going for everybody? So today, I think it's fair to say that I think we should start presenting our research on climate change and the role of analytical chemistry in overcoming climate change on planet Earth. So let's start off with our first member, shall we?
So for introduction, as we all know that climate changes refer to long-term alternation in temperature, weather pattern and atmospheric condition on Earth, largely driven by human activities. Over the past century, the burning of fossil fuels such as coal, oil, and gas has increased the concentration of greenhouse gases in the atmosphere, trapping more heat and causing the planet to warm. This global phenomenon affects not only the environment through rising sea levels, melting glaciers, and extreme weather, but also ecosystem, economies, and human health. Understanding climate change is essential for taking meaningful actions to reduce its impact and ensure a sustainable future for generations to come. So let's see main environmental problems. So we identify the main environmental problems, which is sea level rise, rising global temperature, spread of disease, and ocean acidification. So sea level rise, it happened by melting ice and expansion of warmer seawater. It will flooding of low-lying countries like Maldives or Bangladesh. And then rising global temperature lead to heat wave, drought, and disruption of ecosystem. And the third is spread of disease. Warmer temperature expand the range of disease carried by insects like mosquitoes, like malaria or dengue. And lastly, ocean acidification. Ocean absorb more CO2, it becomes more acidic, it will harm marine life like coral, shellfish, and plankton.
All right, so now moving on to sampling techniques. So sampling techniques are techniques that we use to obtain samples from the environment. Now, these samples are important because we can use these samples to extract data from them. So the first sampling technique we can use is called air sampling. Now, the purpose of air sampling is to measure greenhouse gases such as CO2 or also ozone layers. So there's two ways you can go with air sampling. One is by grab sampling, which is just you collect gas from one point of time and you analyze it. Or you can use continuous monitoring systems, such as we can use satellites to obtain samples. Now, the second technique is called ice core sampling. Now, ice core sampling is very vital in the long-term historical climate data. So what they will use is that they'll drill core ice cores from Antarctica or the Arctic circles to obtain the air samples that are stuck within this ice. So now moving on to the third sampling technique is called ocean and soil sampling. Now this purpose is to detect ocean acidification and also the soil carbon content. The example of this is that by the pH sampling in coral reefs in water to study the CO2 absorption. Last but not least, another method we can use to obtain samples is by remote sensing or satellite sampling. So the purpose of this is to obtain samples from a much wider area. So we can use the satellites from the space in order to gather samples from a wide range of area in order to be analyzed. All right, now let's moving on to analytical techniques. So how does analytical technique differ from sampling technique is that analytical techniques they abstract the data from the samples that we acquired early on. So the first analytical technique we can use is gas chromatography. So in gas chromatography, also known as GC, CH4 or NO2 can be detected. So we can use detectors like FID for hydrocarbons or ECD for halocarbons. So another analytical technique that we can use is non-dispersive infrared spectroscopy, also known as NDIR. So NDIR is continuous CO2 monitoring due to its specificity and also a low detection limit, which means we can observe the CO2 levels for a long amount of time. So another analytical technique is mass spectroscopy. So what the mass spectroscopy does is that it's isotope analysis where it's used to identify fossil fuel derivatives of CO2. So we can use this in carbon source tracking and also ocean acidification studies. And the fourth technique we can use is called UV visible spectrophotometry. So this is very, very useful in detecting ozone levels and NO2 in the atmosphere. Last but not least is high performance liquid chromatography, or also known as HPLC in short. So HPLC is used in detecting organic aerosols, brown carbon, or also humic-like substances in the air particles. So this is not used in detecting gas particles, but it's more towards liquids. So it can also be used to detect organic acids in rainwater, or also in monitoring biomarkers in sources of water around the world. So that is all from analytical techniques.
Okay, thank you, Ishwa. Since we have already heard about the key analytical and sampling methods involved in climate change studies, so now I will explain how these techniques compare in terms of their benefits and limitations. So, these methods is actually important in helping scientists monitor, measure, and understand the gases that contribute to global warming. So, for the first one is GC, which is chromatography. Gas chromatography is a highly sensitive analytical method used to detect and quantify the greenhouse gases like methane, carbon dioxide, and nitrous oxide in atmospheric samples. So it's excellent for lab-based studies where precision is important. However, it's not suitable for real-time or field monitoring as it requires lab equipment and setup. For the second one is non-dispersive infrared spectroscopy, NDIR. NDIR is an also analytical method commonly used to measure carbon dioxide levels in the air. So it is portable, non-destructive, and allows real-time monitoring, making it ideal for observing carbon dioxide emissions in cities or factories. So, but the accuracy can be affected by the presence of the other interfering gases, and it is less precise than lab-based methods. For the third one, isotope ratio mass spectrometry, IRMS, which is very precise analytical technique used to determine the isotopic composition of gases, especially carbon dioxide. This helps researchers to identify whether carbon dioxide comes from fossil fuel burning or deforestation or natural process. However, it is very expensive and requires skilled personnel and is mostly used in research laboratories. Can for next slide. For Fourier transform infrared spectroscopy (FTIR), FTIR can simultaneously detect multiple greenhouse gases, include carbon dioxide, methane, and nitrous oxide. So this can make it very useful for understanding the overall composition of the atmospheric pollution. But this equipment is costly, high initial cost, and the readings can be affected by environmental conditions like temperature and humidity. For the last one is remote sensing via satellite, which is the sampling method that collects atmospheric data from space, often focus on gases like carbon dioxide, methane, and even water vapor. It allows scientists to observe global emission trends over time. However, it has lower resolution and less accuracy than direct measurement on the ground. So, in conclusion, analytical chemistry provides a powerful set of tools for monitoring and understand the gases driving climate change. So each method has its pros and cons, whether it's detecting CO2 in real time with NDIR, identifying gas sources using IRMS, or tracking global trends with satellite data. So that's all from me.
Right, thank you, lead scientist. So today, after thorough investigation and research, we had come to a conclusion that the most recommended analytical approach is gas chromatography and high performance liquid chromatography. We choose gas chromatography because it has multiplex greenhouse gas analysis. Meanwhile, we choose HPLC because of its broad applicability and high versatility. All right, next slide. We had come to the conclusion because gas chromatography is highly sensitive, which make it capable of detecting trace levels of greenhouse gases, in which GC is widely used in monitoring to quantify volatile compounds like CH4, CO2, and N2O in the ozone layer of the Earth. There are a few of the there are a few of advantages and disadvantages of gas chromatography, which is I would like to break it down. The advantages of GC is high sensitivity and precision, has fast analysis, excellent for gases and VOCs, and can be automated. But gas chromatography are limited to volatile compounds only. Besides, it requires sample preparation and expensive equipment and maintenance. And also, skilled operators are also needed. Okay, next. Next slide, please. Mm, but I think HPLC has complement the advantages of GC because HPLC was commonly used technique to analyze wide range of compounds, and it complement the weakness of gas chromatography that can only analyze gases. HPLC has a wide range of analytes, good for water and soil studies, high resolution and accuracy, and less take for volatile sample. But the disadvantages is HPLC are not suitable for gases, which is why we are using GC. Also, HPLC need to use solvent in order to analyze the compounds, and basically HPLC has a slower rate than GC, even though it's for a simple mixture. Besides that, it is also very expensive to maintain the intensive in HPLC. And that is and that is from me. Thank you.
Okay, I'll be explaining the key resource required to ensure the effectiveness, accuracy, and sustainability of our project, which is I give you four, which is the first one is expensive equipment. The second one is need for to skilled workers. The third one is costly chemicals, and the last one is data storage system. Okay, let's move to the next slide. Okay, so let's look to the expensive equipment first. So first, we need to consider the high cost of analytical instruments, device such as gas chromatography, mass spectrometry, are extremely accurate and reliable. But they come with a high price tag, which is not only for purchasing, but also for maintenance and calibration. So these instruments are essential for detecting and identifying chemical compounds in complex samples. The second one is need for skilled workers. So next, we require trained and skilled personnel to operate these instruments. These tools are not plug and play. They need operators who understand both the equipment and the analytical methods. Without proper expertise, the risk of generating inaccurate results or damaging the instruments increase significantly. The third one is costly chemicals. So analytical procedures also demand high purity chemicals and reagents, which are expensive. So this includes solvents, standards, and reagents needed for reaction or calibrations. So we must using the low quality chemicals could compromise data integrity and accuracy. So it's important to invest in proper lab grade materials. And the last one is data storage system. Lastly, all the results produced must be properly stored and managed. That includes both physical and digital data. For long-term analysis and traceability, we need a reliable data storage system with backup solutions and compatible software for data processing, retrieval, and sharing among team members. So, in short, efficient and reliable chemicals analysis is only possible if we invest in the right tools, the right people, quality materials, and a strong data management system. So, all these resources are crucial to maintain high standards and assure the success of our research. So, that's all for me.
Good everyone, we are back to me. So, as the lead scientist here, as a lead chemistry here, I would like to walk you guys through into our 5-year roadmap to tackle climate change by leveraging two of the most powerful tools in modern analytical chemistry, which is, which is I mentioned earlier, gas chromatography and high performance liquid chromatography. So, why climate action needs chemistry? Climate change is no longer a distant threat. It is a present reality. Greenhouse gases, industrial emissions, and chemical pollutants contribute all contribute to global warming and ecosystem degradation. But how do we measure, we track, and eventually solve this? This is where the analytical chemistry comes in, especially for gas chromatography for air and HPLC for water and soil monitoring. So I would like you guys to see the overview of my 5 years timeline, which is I had already. Please take a quick look at my structured 5-year plan from 2025 to 2030. Okay, so in year one we would like to do the foundation and setup and planning. In year two, to we are together fast sampling and method of optimization. In year three, to do data analysis and impact assessment. In year four, we are to develop a solution and pilot testing. And in year five, we can finally we can finally undergo implementation and policy integration. So let me break each year down in more detail. Okay, so first of all, in year one, in order to building the foundation, we need to focus on acquiring and setting up GC and HPLC instrumentation. We need to secure funding so that we could continue on our research. Basically, because both GC and HPLC instruments are very expensive. So, besides that, we also in need to train our team on precise sampling and analysis technique, while also establishing baseline measurements for air, water, and soil quality. In this year also, we are to identify key chemical markers like CO2 and CH4 for gas chromatography, and for HPLC, nitrates, phenol, and heavy metals. We also initiate partnership with university environmental agencies to secure the funding of our long-term studies. Okay, in year two, we are to find real-world samplings with instruments calibrated and personnel trained worker. So year 2 is all about our field work. We will conduct seasonal sampling in urban, industrial, and agricultural zones while also optimizing our GC methods for greenhouse gases and fine-tune our HPLC protocols to analyze pollutants from runoff and industrial waste. This also help us in validate our methods through repeated testings and quality control. The aim is to ensure that our data is not just precise but reliable across time and condition. Okay, move on to year 3, uh, which is we are experimenting in data analysis and environmental impact. So this is where the things get exciting because we start analyzing the data trends, mapping pollution hotspots using tools, and correlating emissions with local activities like agriculture, transportation, or industry. We do this in order to prepare report to visualize how different regions are contributing climate-related chemical imbalances. This data and our data will tell a story that where the problem is, how fast it's growing, and who it affects most. Because we are conducting research on climate change, so the one who will be affected most is humans itself. Okay, moving on to year 4, we are to design and testing the solution because we already have a clear picture of the problem as we are already beginning to develop solutions. We could be the developed solution could be emission control system based on gas concentration, pollution mitigation filters, or water treatments, and also develop new guidelines for industry waste handling. It'll improve. Finally, in year 5, where we could finally validate the implementation and policy support, we could scale up the solution and influence policy and also establish continuous monitoring by doing implement solution in key regions. We also to install continuous monitoring stations using automated GC and HPLC system while also deliver comprehensive reports to local governments and stakeholders. This goal is just not to fix but to prevent future environmental damage. So, by the end of year 5, we are to expect a complete climate monitoring framework tailored to our region. Besides, we also want to reduce emissions and improve our water and soil quality. And most importantly, we need to develop a real science-driven contribution to the global climate fight. Climate change may be a very massive challenges for us, but we are not powerless. Through our analytical technique like GC and HPLC, we are not just to watch the environment change. We are to measure, to understand, and intervening before it's too late. All right, everyone, thank you for attention. That's all from me. Thank you.
Okay, so I want to conclude climate change is one of the most serious environmental challenges facing our planet. So, as we all know, the impacts are wide-ranging and severe. So, analytical chemistry plays the vital role in understanding and combating like climate change. It provides the data needed for climate modeling and emission control strategies. So, combining understanding with chemical analysis is essential to protecting our planet and ensuring a sustainable future. Okay, that's all from me.
All right. Thank you, Ashraf, for the conclusion. Uh, it's safe to say that what you guys presented today is a very, very in-depth, researched, and also very uh, properly given answer to climate change. It is true that as a analytical chemist, we play a very, very important role in helping humanity as a whole to overcome climate change. And what you guys presented today is the framework for what the future generation can use to overcome and also to monitor climate change. So thank you everyone and congratulations on finishing your research.
Thank you.
Thank you, everyone.
Thank you.
Bye.
Dah kot, dah.
Dah habis eh?
Dah tak suka jadi
Dia
fake tu.
bukan